Hi students, so today we start Math Question Bank 21. Today I'm going to look at some questions related to least square curve fitting. Now this subject has become extremely important because of the advent of data science, and many a time if you are asking a candidate or student questions on data science, then these kind of questions will be useful. Now of course curve fitting is not just limited to data science, it's used widely in any representation of data in science, technology and any scholarly domain. So it's important to know how least square curve fits are done. It's important in machine learning also because if you think about it, a lot of things we do in machine learning, even neural networks, deep networks, are nothing but multidimensional curve fitting. I'm Dr. Ganguly. So let's start with the simplest question you can probably devise in least squares or in data science, and that is to fit a line through the following data, and you have three data points and you have to fit a line through it. And you can specifically ask the student to do this using least squares. Of course you can skip this also and let the student figure out what method he or she wants to use. So here you have three data points 1, 2, 3. For each data points you have two coordinates x and y. So for data point 1 x is 1, y is 3. For data point 2 x is 2, y is 4. And for data point 3 x is 4, y is 8. So before I begin the math about how to do this problem, I'm going to simply try to solve it in Microsoft Excel. So in Microsoft Excel, there is a feature that if you plot these 3 points, which I have done here, x versus y, then you can ask Microsoft Excel to fit a trend line through this data. And here I have asked it to fit a linear trend line. So it's fitted this particular trend line here. And this is likely to be due to least square. We are going to actually investigate the problem and see if it is so. Now, of course, one more way to pose this question is to actually ask a student to first do this in Microsoft Excel. Maybe if you are conducting an interview in Zoom or Team, you can ask him or her to do that. And then you can ask them, how do you think this formula is obtained? So let's start with the basic definition of a straight line, which is y is mx plus c. Now, of course, here we have defined x and y as the actual data point. So we will put y hat, and the hat simply means that this is an estimate of the value of y. So this is the real value of y, which we know at 3 points, and y hat is going to be the estimate. So now let us write three equations because we have three data points. So what we are going to do is, for each of these equations, we are going to plug in a point and then get three equations here. So let's start with point number 1. So I get y hat 1 is mx1 plus c, and x1 is 1. So I substitute that here. I get m into 1 plus c, and then I can actually calculate epsilon 1, which is y1 minus y1 hat. Y1 is 3 here. That's the actual value of y at that point, and y1 hat is of course m plus c, which is the predicted value. So I get epsilon 1 is 3 minus m minus c. So that's something which you can clearly see from this equation, that epsilon 1 is y1 minus y1 hat. Now this is sometime known as the residual value. So at data point 1 we have calculated the residual between the actual data point 3 and the predicted data point, which is m plus c. Now the same thing we continue with data point 2. So in that case we have y hat 2 is mx2 plus c. Now x2 is simply 2, so I substitute it here, and then I get epsilon 2 is y2 minus y2 hat, which gives me 4. See, the value of y here is 4. So 4 minus 2m minus c. 2m minus c is simply this value here for y hat 2. Now we come to point number 3, and data point 3 we have y hat 3 is mx3 plus c. So I substitute x3 is 4 here. I get m into 4 plus c, and now I can get epsilon 3 is y3 minus y3 hat, and so y3 here you can see is 8. So I have 8 here, and then y3 hat is 4m plus c. So I get 8 minus 4m minus c. So these are the three residuals here. Now, what we do in the least square type of approach is we create an objective function or function which is actually the sum of the squared. So essentially you can see that this L is given as I is 1, 2, 3, epsilon I square. Now 3 is because I have chosen 3 points here. Now of course if you had 4 points, then you would have 4 values of epsilon here. So again you get the hang of this method. You can actually use any number of points you have. Now once I have this definition, I can expand it out. So I expand it out as epsilon 1 square plus epsilon 2 square plus epsilon 3 square, where I have taken these three values and I have simply put them here. So now we have got a problem which we can pose as a problem in calculus. So you can think of this value of L or function L as a function of M and C, and then I need to minimize this function. Now of course if I was able to calculate the values of M and C for which this L is minimized, then I can substitute those values of M and C here and I can obtain the least square fit for this particular problem. So this is in essence the least square method, and let's try to do this problem now. So I have written this LMC as a function here. Now this is a calculus problem. So what we can do is we can try to find the minimum point of this function L. So to do that, I take the derivative of L by M and set it to 0, and I take the derivative of L with respect to C and set it equal to 0. Remember, M and C are the two variables here, and since this is a problem with two variables, I have to take partial derivatives. Now what happens with partial derivatives is that when I take the derivative of L with respect to M, I have to treat C as a constant, but I can treat M as a variable with which I am differentiating. So to do that, I immediately get the first term as 2 into 3 minus M minus C, and then I have to differentiate this term here with respect to M, which gives me minus 1. Now we take the second term, so I get 2 4 minus 2M minus C, and I again differentiate this term inside and I get minus 2 here because the derivative of minus 2M is minus 2. Remember, C is being taken as a constant when we are differentiating with respect to M. This is the partial derivative, so we are differentiating this only with respect to M. Now the third term will give me 2 into 8 minus 4M minus C, and then the derivative of the term minus 4M is going to be minus 4, and then this entire derivative is going to be equal to 0. So that's something from calculus we know. We are trying to find the stationary point of this function LMC. So now what I can do, I have these 2's here in front of the brackets. I can remove them. I have the negative sign here. I can remove these three negative signs also, and then I can try to write this in a simpler form. So I do that here. The first term becomes 3 minus M minus C. The second term would have a multiplication by 2. So I get 8 minus 4M minus 2C. The third term would have a multiplication by 4. So I get 32 minus 16M minus 4C. So this is the equation here. Now I can further simplify this. You can clearly see that there are certain values of M here. So there is a 16, there is a 4, that would be 20, and 121. So I can write this as minus 21M. I have some constant numbers here. 32 plus 8 is 40 and 343. So I have the 43 here. And for the C, I have 4C and 2C and C. So that gives me 4 plus 2 6 plus 1 7. So I get this equation in pink. Now similarly, I take the derivative of L with respect to C. This is actually simpler because what I have here is simply I take the derivative, and in each case what will happen is that this negative C derivative of that is going to be simply minus 1 in all these three subterms. So the first term becomes 2 into 3 minus M minus C into minus 1. The next term becomes 2 4 minus 2m minus c into minus 1, and 2 8 minus 4m minus c into minus 1. Remember that in this differentiation I am treating m to be a constant here, so the differential is only with respect to c. It's the partial derivative. Now I can simplify this further here. I can remove these two here in front of the brackets, and these negative ones I can also remove. So I then get 3 minus m minus c, 4 minus 2m minus c, 8 minus 4m minus c, and this entire thing is 0. Now let's sum all the terms here. So we have 8 plus 4, that is 12, plus 3 15. We have 15 here. We have 4 plus 2, that is 6, plus 1 7. So I have 7 here, and here I have c, c and c, so I have 3c here. Now these two equations in pink are what has come out of this particular process of differentiation, and you can realize from your knowledge of mathematics that I can solve these two simultaneous equations for m and c, and then I will be able to get this fit here which is dependent on values of m and c. So let's do that in the next slide. So again, that's what I have done here. I have taken these two equations. Now the second equation which I have here, I can see if I multiply this equation by 3, then I will get a term involving 21m. So I do that here. So I multiply this equation by 3. So I get 45 minus 21m minus 9c equals 0. And I can then subtract these two equations here. So I will get 2 minus 2c equal to 0 or c equal to 1. So I have got one of the constants for that particular fit. Now I can take c is 1 and substitute in one of those equations, and so I can solve it and I get m is 12 by 7. So I can then clearly see that this equation y hat is mx plus c is the same as y hat is 12 by 7 x plus 1, because m is 12 by 7 and we also see that c is 1. So this is the equation. Now if you actually take the value of 12 by 7, it comes to 1.7143. So this is the least square fit for this particular set of 3 data points, and Microsoft Excel gives me this trend line straight away. So of course nowadays you are very much able to get these kind of equations very quickly if you use software like Excel. But of course, you can be asked this question in any data science interview to make sure that you know how to do the simplest possible least square fit scenario. Now let's somewhat complicate this problem, and the question becomes, fit this particular curve through the following data, that is a e to the power bx, and the data points are exactly the same. Now this is an exponential fit, and the exponential fit is often used in many cases because it can sometimes be better if you want to fit certain type of nonlinear data. So let's try to do this problem. Now before we begin this problem, let's simply plot this curve once again in Microsoft Excel, and then I ask Excel to give the equation for an exponential fit. So this is what I get from Excel. The trend line is y is 2.1213 e to the power 0.3297. So let's see how to get this equation. Now again, you can reframe this question. You can ask a student to do this in Excel if you are conducting some kind of interview in Zoom or Team, and then you can ask them to figure out how this equation is obtained. So we'll try to do that next. So we have these three data points here, and what I'm going to do is I'm going to simplify my life here by taking logs. In the next lecture, I'm going to look at a different way to solve this problem, but let's now keep our life simple. So if I take log on both sides of this equation, I will get log y hat is log a plus bx. So remember here I have two terms, so there will be a term log a, the second term will be bx into log of e, and I'm taking natural log here, so log of e will simply be 1, and so I will get log y hat is log a plus bx. Again remember, y hat is the estimate and y is the actual value, which we know only at 3 points. Now let's change the nomenclature so that we can think of this whole thing as a line. So let's say this is z hat is mx plus c, or z hat is mx plus c. So now what we have done is we have said z hat is log y hat, also z is log y, m is b, c is log a is e to the power c. So now we see, just by comparison of these two, I can see that m is going to be b and c is going to be log a. So these equations are there. I can also obtain a is e to the power c. So I can write this y hat as e to the power c, which is the same as a, and e to the power of mx, which is same as e to the power bx. So, so essentially, if I am able to calculate c and m, which are obtained from this line here, then I can figure out the exponential fit. Let's try to do that now. So what I have done here is I have taken these 3 points and I have once again expanded it out. So I take z1 hat, that becomes mx1 plus c. So m into 1, remember x1 is 1 plus c. So epsilon 1 becomes z1 minus z1 hat. So this becomes log 3 minus m minus c. Remember that z1 is log of y, and I'm not taking the log of y here, I'm just keeping it as log 3. We can later simplify it and calculate the math. Similarly, for the point z2, I would have x2 is 2 here, so I put x2 is 2. And also then what happens, epsilon 2 becomes z2 minus z hat 2. So z2 of course is the second point, which would be y here, so log 4 because y is 4 here, and then minus 2m minus c because we have 2m plus c here. Z3 is going to become mx3 plus c, so I substitute x3 is 4 here, so I get m into 4 plus c, and then epsilon 3 becomes z3 minus z hat 3 is log 8 minus 4m minus c. This should actually be epsilon 3 here, that's a typo. So then what I do is I calculate the objective function, which is the sum square, and so each of these epsilon 1 square plus epsilon 2 square plus epsilon 3 square is calculated. So I get this nice looking equation here, which of course you realize is just a function of m and c, and therefore I have converted this problem into an optimization problem. Now let's take this function L. We know this is a function of m and c, and we want to find the minimum point of this function. So I can differentiate this with respect to c, I can differentiate it with respect to m, and I can set them equal to 0. So again, that's a very simple exercise in differentiation, which can be done by any student at the class 12 level, also grade 12 level. So let us simply differentiate it. So again, you remember here that when we are differentiating with respect to c, we are treating m as a constant. So in each case, you will have 2 into this term here, and then the derivative of minus c is going to be minus 1. Same thing here, 2 into the term here, and derivative of minus c is minus 1, and the same thing here. Now I can remove these 2's in front of the bracket, the negative ones in the brackets here, and I get log 3 minus m minus c, log 4 minus 2m minus c, log 8 minus 4m minus c equal to 0. I simplify this further, so you can see here m, there is a 4, 2 and 1, so there is a 7m, there is a c and c, so there is a plus 3c, and then there is a log 3, log 4 and log 8. So what I have done is I have taken the m and c terms to the right hand side, and I've kept the log terms in the left hand side, and then I flipped the equation to get it in the form 7m plus 3c is this constant value. Now the next derivative is dl by dm. So in that case again we get all these terms 2 into that expression, and then we have to differentiate the minus m term here, which gives me minus 1. The minus 2m term gives me minus 2. The minus 4m term gives me minus 4. Remember here c is treated as a constant, and so again I expand this out, I remove these 2's here, I removed the negative signs, and so the first term here remains exactly same. The second term here gets multiplied by the 2 here, and the third term here gets multiplied by the 4. And then I simplify this equation and I get this equation here. So these two equations in pink are simultaneous equation, and you know from your background in high school and college that you can solve these for m and c, and then that's going to help you get the equation of the line. So that's what we have done here. We have these two equations here, and you can see that I could actually do some very simple calculations. I could multiply the first equation by 3, and then I could subtract these two equations. So what that would do is that would remove m. So let's do that. So I get 7c minus 9c because I multiplied this first equation by 3, and I get this term log 3 plus log 4 plus I get this term here, and I subtract minus 3 times this term here. So essentially just a solution of simultaneous equations. After doing some math, I get C is 0.7520, I get M is 0.3297. So I've obtained C and M, but now I need to get A and B because the y hat is expressed in terms of A and B. So what I do is I get M equals to B. Remember that was the definition we did before. So B is simply going to be the value of M, that is 0.3297. And remember C was log A and A was e to the power C. So I can calculate e to the power C from my calculator, and C is given here. So I get 2.12132. So this is the solution. Y hat is 2.1213 e to the power 0.3297x. Let's now revisit the exponential trend line we got in Excel. So you see Excel actually gives me this particular value here, and you can clearly see the value I obtained using calculus and basic first principles is exactly the same value. So these two questions are extremely useful in testing a student's knowledge of least square of data science, and they can be done in many simple interview settings and so on. So if you are conducting the interview on Zoom or team, you can give a student maybe 15 minutes to solve any one of these problems, and you can let them use Excel also if they want. Now question 3 is a very simple trick question. I have just put it here because sometimes people ask this question to give a curved ball or a googly to the student. So essentially the question is fit a line using the least square approach, and you are given two data points here. Now, of course, this is a trick question. So the solution is that since only two data points are given, you can actually fit a line through it. You don't need least square. So the line is going to be y is mx plus c. You substitute x and y in this line. So you get 3 is m1 plus c for the first data point. You get 4 is m2 plus c for the second data point. You can very simply subtract these two equations and get m is 1, and you get c is 2. So the line is going to be y is x plus 2. Now just to check, if you put this problem in Microsoft Excel and tell it to do this linear trend line, it's going to put y is x plus 2 here. So this is a very easy problem. It's a trick problem. Sometimes people get intensely confused if you give them this particular problem. So this was a basic introduction to least square. Now one of the interesting thing is that the second problem which we do today, if you do it using a different method, that is you do not take the log on both sides of that equation, you actually use the exponential curve, and you actually do a kind of nonlinear problem, you will get a slightly different solution. So that I'm going to do in my next question bank, and we are going to end up with some complicated equation which will require Newton-Raphson to be solved. Now it's interesting that many software such as Microsoft Excel do not seem to use that approach, because in many cases the answers you get using that approach will be very similar to whatever we have got with the approach today. But the right way to solve this problem is actually to use the approach we solved today to get a first solution to the problem or the initial guess, and then actually solve the nonlinear problem using the Newton-Raphson method. So in the next class, I'm going to take a look at that, and maybe we are going to write some Python code also to solve this problem using Newton-Raphson method, because then that's going to test the student's capability not only in math but also in programming and numerical computation with Python, as well as maybe some plotting exercises using Python. So I'll see you in my next video. See you then.